So in this video, I'm going to have a look at how you can solve questions using the Suvat equations, or their proper name, the kinematic equations. The first thing to check is that you're happy with what all the symbols mean. So we have acceleration is given the symbol A, initial velocity the symbol U, the final velocity the symbol V, the displacement the symbol S, and the time the symbol T. So here are my tips for success in the questions. First of all, write down space to put all the S, U, V, A and T. Then, really importantly, draw an arrow or arrows showing which way is positive and which way is negative. Thirdly, fill in all the information that you can, making sure that you convert into standard units. Put a question mark against the S, U, V, A or T that you're trying to find. Then put a cross against the thing you don't know and you don't care about. Then choose the appropriate equation from the ones that there are. And finally, rearrange it to get the thing you want, put the numbers in, and then give your answer to a sensible number of significant figures with units. Before we launch into some examples, the common problems that is worth being aware of before you start is to make sure, can you actually distinguish in your handwriting between your U's and your V's, as this can cause you a big issue if you can't. The way that I make sure mine are okay is that I always do a tail on my U and I always aim for a point on my V. And then even if I do something that could be a V if it didn't have a tail, I know that's got a tail so it must be a U, and even if I don't manage a very good point, there's no tail, that would be a V. Second thing, have you managed to extract any hidden information in the question? For example, if it says from rest, that would mean that U, the initial velocity, was 0. Or if it says slows down to rest, then that would mean that V, the final velocity, was 0. Thirdly, did you actually define which were your positive and negative directions, or did you ignore that step in the tips for success? And finally, you might forget that in the vertical direction, acceleration is given by g, the acceleration due to gravity. But you have to be really careful because that's sometimes plus g or minus g, depending on whether you've defined upwards or downwards as positive or negative. Okay, so let's try our first example question. A ball is dropped from rest off the side of a building which is 50 metres high. How long does it take the ball to reach the ground? So the first step was to write down space for all the information for the Suvat. So we'd have S, U, V, A and T. And if you're being good, you'll put a little equals sign for each of those. Okay, so the next step is to decide which way I'm going to call positive and which negative. So I'm going to draw an arrow because I'm going to call down positive. Okay, so now I can fill in all the information of the S, U, V, A and T that I know. So that will be that I know S is going to be plus 50 metres because it's 50 metres down. I know that U, the initial velocity, is 0 because it was from rest. Really, I should have put units in those. I know that V, the final velocity, actually, I don't know that. The acceleration I know is g, so will be plus 9.81 because I know that downwards is positive because I decided that. Okay, so then my next step was to put a question mark against the thing that I wanted and put a cross against the thing that I don't know and don't care about, which in this case was V. Now, the reason for putting this cross is that actually makes it very easy to do the next step, which is choose the appropriate equation. So let's enlarge these equations a bit to make it a bit easier to see. So I've got all of those equations there, and I need to pick the one which doesn't have the thing which I don't know and I don't care about. So in this case, that was the V, which I don't know and don't care about. So I'm looking for the equation which doesn't have a V in, which is that one. So let's move that out of the way, and I can now write in that I need to use the equation s equals ut plus a half at squared. Now I'm into my last step, which is to rearrange the equation, put the numbers in and give my answer to sensible significant figures with a unit. I can make things slightly easier for myself by noticing that u is 0 and therefore u times t will be 0, so I can cross that out. Next I'm going to multiply both sides by 2, which will give me 2s equals at squared. Next I'm going to divide both sides by a, which will give me 2s over a equals t squared. And finally I'm going to take the square root of both sides, which will give me the square root of 2s over a equals t. So I'm almost there. Let's move this out of the way to give me a little bit more space. So I can now say that t, the time, is equal to the square root of 2 times 50 divided by 9.81, which will be equal to 3.19. Rounded that to a sensible number of significant figures, and then I need my units, which will be seconds. Okay, so let's try a second example. An aircraft has a landing velocity of 50 meters per second and decelerates uniformly at 10 meters per second squared until its velocity is reduced to 10 meters per second. Calculate the distance travelled whilst it's slowing down. So step 1 again was to write out the Suvat, and then step 2 was to decide which way is positive and which way is negative. And in this case that's really deciding that the aircraft is moving with a positive speed, and then because we're told it decelerates, that means that this must be negative. So let's move to the third step, which was filling in all the information. So that was that our starting speed is 50 meters per second, that our final speed is 10 meters per second, our acceleration is minus, and minus is really important, was minus 10 meters per second squared, and our next step was to put a question mark next to the thing that we're asked for, and we're asked for the distance travelled, so we put a question mark against the s, which means our next step is to say we don't know and we don't care about t. So then what we need to do is have a look at the equations, and we're looking for the one that will help us find s, so we want to look for the one which doesn't have t in it, and that prize goes to v squared equals u squared plus 2as. So now let's move that out of the way and write in the equation which we're going to use, v squared equals u squared plus 2as. Now we need to rearrange this, and first of all I'm going to subtract u squared from both sides, so that will give me v squared minus u squared equals 2as, and then I'm going to divide both sides by 2a, which will give me v squared minus u squared divided by 2a equals s. And now I need to put the numbers in so I can find the s, so let's do that. So that will give me s equals, and my v squared will be 10 squared minus my u squared, which was 50 squared, divided by 2 times the acceleration, which will be 2 times minus 10, and that will give me 100 minus 2,500 divided by minus 20, and that will give me 120, and the last thing I need to do is put the units meters. So let's look at the final example which I'm going to do, which is a ball is thrown vertically upwards at 15 meters per second. What is the maximum height that it reaches? So let's first of all write out the Suvat. Let's next decide that I'm going to call upwards positive and downwards negative. Then next step, we can fill in the information that we have, which is that the initial velocity is plus 15 because it's going up. Let's put the units as well to be good. And then the acceleration is going to be the acceleration due to gravity, but that's going to be down, so that's going to be minus 9.8 meters per second squared. And that appears that all we've got, but we need to remember to look for the hidden information. And the hidden information here is that when it gets to its maximum height, that must mean that it has stopped. So its final velocity will be 0. And then we need to decide what have we been asked to find, the maximum height, so that's S, which means we don't know t and we don't care about t. So that means we can now choose the equation that we want, which is the one that doesn't have t in it. And that is in fact the same equation that we used in the last question, which is the v squared equals u squared plus 2as. And we in fact need to rearrange it in exactly the same way as in the last question, which will give us s equals v squared minus u squared over 2a. And then we need to put in the numbers, which will give us s equals v squared, which is 0, minus 15 squared, which is 225, divided by 2 times the acceleration, which was minus 9.8, which gives us 11.479, blah, 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 blah. But we need our last sensible step, which is we need sensible significant figures, so I'll make that 11.5, and then we need a unit, which gives us 11.5 meters. So to finish, there is to remind you the steps that we followed to solve those questions.